Good afternoon. Welcome to the 7th and final meeting of the Communications Security Reliability and Interoperability Council 9, which I formally declare to be open. Thank you all for being here today. It's been a while since we gathered, so it's nice to see everyone. It's been 6 months, which is the longest. I've not been at a CSRIC meeting in probably a decade. So administrative items first. For those on Teams, I ask that everyone turn off their camera and microphone unless you're speaking. If you wish to speak, please use the hand function and we will call on you. For those in the room, if you wish to speak, please turn your tent card on its side so it's vertical. And when you're called, the microphones on the table are equipped with 2 buttons. The one on the right will turn red, which means it's hot, and then you can speak. For those who are giving presentations, please say next when you're ready for the next slide so Kurian can move the slides along. Today, we're going to be presented with, for deliberation and votes, 3 reports. Report on best practices for the use of artificial intelligence, machine learning systems specifically intended for public safety networks by Working Group 1 co-chairs Jen, Jason, and VJ. We're then going to be presented with a report on recommendations for preventing adverse impacts on PSAPs and NG 911 from 911 calls made through alternative network options by Working Group 2 co-chairs Stephen and Brandon. And then finally, we'll be getting a report on potential security and reliability risks in 6G and recommendations for mitigation from Working Group 3 co-chairs Brian and George. With that, I turn the meeting over to Todd.
Thank you, Suzanne. Great for our final meeting. First of all, I just want to thank you, the entire staff. It's been a time, so I appreciate you guys working through all the challenges that were thrown our way. And I want to thank each of the working groups and the chairs. The work product that you've created, you should really be proud of. And I recognize it's a huge time commitment. And again, thank you so much for putting in the effort to do that. So with that, we're going to jump right into roll call. And I think I'm going through every name on here, right? Or do you want me to skip through?
Say these are the ones on Teams.
You have to call the ones on Teams. Okay. So if Todd does not call your name and you're on Teams, it means that he has notification that you're on Teams. Thanks.
Okay, let's start with Brandon Abley. Present. Richard Barron.
Present on Teams.
Alexandra Blaskin. Alexandra from Consumer Technology Association. Okay. Billy Brown, I got you here. Billy Bob. Wade Buckner. Wade Buckner. Douglas Campbell. Douglas Campbell. Stephen Devine. Here. Luis Eduardo. Luis Eduardo. Paul Eisler. Paul Eisler. Ben Goldsmith. Ben Goldsmith. Michael Hayes. Michael Hayes. Puneet Jain. Puneet from Intel. George Youngbluth. George Youngbluth. I'm not batting very well here, am I? Ankur Kapoor. Okay, thank you. Lauren Kravitz. Leah Misseldine. Leah. Douglas Montgomery. Douglas Montgomery from NIST. Brian Murray. Brian Murray from Harris County. Morgan O'Brien. Morgan O'Brien. He said he's present. Brian Murray, we got you, okay. Jennifer Oberhausen.
Present.
Jennifer, great, thank you. Jared Owen. Jared Owen. Scott Paretsky. It's good to see you. Myself. Michael Reagan. Michael Reagan from TIA. Travis Russell. Travis Russell.
I know he's actually not going to be here.
Okay. Sean Scott. Sean Scott. Brian Tegmeyer. George Woodward. And Henry Young. Henry Young. Okay, anybody else join after?
Paul Eisler, U.S. Telecom.
Okay, great. Paul Eisler.
Wade Buckner
Wade Buckner joined as well. Okay,
and
Paul
Jeff
Eisler.
Bratcher, BRAT.
Jeff Bratcher had him, and Wade Buckner. Great. I think we have a quorum. Let me just double check real quick here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're missing 15. So we have a quorum. Great. Okay, thank you. Okay. All right, so before we get started, I just want to remind everyone of the administrative procedures here. After the report presentation concludes, the floor will be open for questions, comments, and deliberation. Just place your tent card on end if you're here in the room, or use the hand raise function on Teams to indicate your desire to speak. So with that, we'll start with Working Group 1 with Jen Oberhausen, Vijay Garbani, and Jason Hogg to present a report on best practices for the use of artificial intelligence machine learning systems specifically intended for public safety network.
Hey, good morning from Seattle and good afternoon to the folks on the East Coast. Can everybody hear me okay?
Yes.
Perfect, thank you. My name is Jason Hogg, and I'm joined by Vijay Garbani and Jen Oberhausen, who are also co-chairs for Working Group 1. Vijay is the Chief Data Scientist and Head of Machine Learning at Vail Systems. Jen is Microsoft Telecom Counsel, and I'm SVP of Engineering for Iridius. As you know, Working Group 1 has been focusing on evaluating how to harness AI and ML systems to ensure the security, reliability, and integrity of the nation's communications networks. We've already delivered 2 papers, and our goal for today is to walk through the third and final paper, which is focused on best practices for the use of AI and ML, specifically intended for public safety network. Next slide, please. Working Group 1 had a reasonably large group with about 32 different members, sort of fluctuating at different times. In addition to showing the names of the participants, as people see here, we wanted to take this opportunity to thank everyone in the working group for their contributions over the last 2 years. I know, speaking for myself and probably most members of the team, it's been a long but very rewarding journey. For this third report, we did want to call out a couple of special thank yous. Our editorial team, Tim May, Lauren Kravitz, Rob Cantu, and Devin Christensen, amazing time and commitment that they've actually made. We also wanted to call out a couple of members of the working group who we felt went above and beyond. Andy Drozd and Jana Westover, both who spent sort of a significant time creating content. But I also don't want to actually mistakenly not recognize that many other members of the working group also created content. And so thank you to those folks. We also wanted to do a special call out to Corey and Jacob from the FCC who helped guide us, and obviously Susan Cameron and Zenji Nakazawa who have been fantastic with their ongoing sponsorship. So this slide actually shows the alternatives as well. Thank you. Next slide, please. So as we mentioned, we've been tasked with writing 3 different papers. The first two papers we've already completed and submitted, and the third paper is what we're walking through today. Next slide, please. Okay, so for this slide, the FCC directed us to actually consider recommending sound policies and practices for implementing AI within the public safety's communications environment, whilst also preventing and mitigating harms to the security, reliability, and integrity of the actual public safety and response networks. For the remainder of this discussion, we're going to talk through how we scoped the work stream. We're going to talk about AI adoption within the public safety communications network, where it's at and where we think it's going. We're also going to talk about how we evaluated AI risks, building some of the work and the actual framework that we used in paper 2. We're also going to give a quick overview of 3 different scenarios that we evaluated. And then finally, we're going to provide an overview of the recommendations to public safety purchases of AI, the FCC, and public safety industry stakeholders. So with that, I'll now hand over to Vijay, who will actually talk us through in more detail how we scoped the work stream.
Thank you, Jason. I hope everybody can hear me. And thanks for the opportunity to present and represent the work that was done by the working group members. So I'll continue from slide 6. This specific report examines the role of AI/ML in public safety networks, including understanding where such systems can be used and how to prevent and mitigate harms to the security, reliability, and integrity of public safety and emergency response networks. For this particular report, the working group examined several scenarios where AI/ML can be and indeed is being used, and more importantly, where the working group decided that AI/ML should stay out. As we did in report 2, we use the NIST AI risk management framework to analyze these best practices. Next slide, please. The working group adopted the areas defined in the DHS emergency communication ecosystem, as you see here, to structure the report. In this ecosystem, the working group focused on 3 primary areas. The first was communication from the public to the government. This is represented by the blue shading on the diagram that you can see. And these include 911 calls, tip lines, and non-urgent requests. So this is communication from the public to the government. The second area was communication from the government to the public, represented by the red shading that you see. These include messages for severe weather and instructional messages directing protective actions to save lives and property. The third area was communications between government to government, and this is represented by the orange area that you see on the diagram. These include directing voice and data communications among public safety first responders and emergency support systems to establish command and control. So the focus of the working group was on these 3 major areas. The fourth one, public interaction, CB radio, for instance, the working group decided that we will not address that, as AI implementations at the level of consumer devices are beyond the scope of the Commission's task. Deliberating further, the working group decided to use the term Public Safety Communication Environment, or PSCE, as opposed to Public Safety Networks. The group felt that PSN, or Public Safety Network, was not authoritatively defined, and stakeholders' view differed on whether the term should include portions of commercial network used for public safety. We felt that using PSCE allowed the working group to describe the role of AI in affecting public safety without implying any new statutory or regulatory definitions of the term public safety networks. So specifically, PSCE consists of 2 networks. First is the network and systems operated by public safety entities, the primary purpose of which is to support public safety communications. The second network is the specific configuration, services, or logical segments of commercial communication infrastructure that are designed to support the public safety mission. For example, priority and preemption services and dedicated interconnection links for 911 provided by the commercial operators. With that, I'm going to hand it over to Jen for the next slide.
Thank you, VJ. The working group noted that the public places high trust in public safety networks and that public safety entities have low tolerance for risks that might increase the likelihood of communications disruption and degradation. The working group also noted that generally, commercial communications networks already provide priority service for authorized public safety communications that's delivered through robust network architecting. For example, in the context of 911 traffic, this means that commercial networks are designed to provide optimal availability and reliability to ensure adherence to regulatory requirements. Network services are also specifically instrumented or adapted to provide consistent, reliable service for public safety, such as routing protocols that deliver 911 calls to the appropriate PSAP. These practices provide definitive, deterministic processes for managing public safety communications that satisfy the public safety mission's high demand for reliability. At this time, the carrier members of the working group indicated that they do not plan to use AI to route emergency 911 calls. That being said, in the report, we do explore PSAPs exploring use of AI to manage call queues, transfer calls, and language translation services. Next slide. Consistent with other CSRIC reports assessing the AI risk to communications networks, including our recent report on recommended best practices for the FCC and industry on the practical use of AI and machine learning from this past September, we adopted the NIST, or National Institute of Standards and Technology, AI Risk Management Framework as our primary tool of evaluating these use cases. Under the NIST framework, characteristics of responsible AI systems include that they are valid and reliable, safe, secure and resilient, accountable and transparent, explainable and interpretable, privacy enhanced, and fair. Next system. Thanks. This report first looks at the reporting and requests for assistance aspect of the emergency communications ecosystem. The report focuses on the public safety network components involved in handling 911 requests, recognizing the role of commercial networks that are outside the scope of this report. Some of the use cases the report looks at include resource overload during surge events, including AI-assisted call triage, queue management, managing demand during surge conditions, pattern recognition during large-scale incidents, and load balancing, routing, and post-incident analysis. The report also looks at translation, transcription, and identification services, as well as triaging non-emergency calls. For example, under that use case, as public safety call takers across the U.S. continue to see increasing call volumes and experience ongoing staffing shortages, we've seen in the real world that several local jurisdictions are employing AI solutions to handle calls to non-emergency numbers, which are typically a 10-digit phone number specified for non-emergency calls. In many jurisdictions, the same personnel respond to both emergency 911 calls and non-emergency calls. So redirecting non-emergency calls to the appropriate agency has the potential to reduce the burden on emergency dispatchers and allow them to focus on responding to true emergencies. There are several different AI providers operating in this space with similar but varying solutions, allowing each local jurisdiction to choose how to implement an AI solution within their own systems. For example, one county in Florida, callers to the Sheriff's Department non-emergency line provide information to an AI call taker, which can then route information to a dispatcher for review and processing. If that AI system detects that a call to a non-emergency number involves an emergency, the call is immediately transferred to a live call taker for emergency dispatch. Moreover, a supervisor is also able to monitor live transcripts and intervene as needed. We've seen similar implementations across different jurisdictions across the country that have been able to process a high percentage of these administrative calls. As noted, there are various risks that could come up under the AI, the NIST risk management framework, and you've seen in this example some of the mitigations that are in place, such as allowing the jurisdiction to determine the appropriate use of the system, as well as keeping a human in the loop to intervene as needed. All right, thank you. I will turn it over to Jason for the next slide.
Hey, thank you, Jen. So scenario 2 focused on the coordination of activities during a public safety event, and specifically the communications that occur between government personnel and agencies. These communications may use communications infrastructure that's publicly accessible, such as cellular networks, or private, such as government-owned LMI networks. 3 different use cases were considered, as outlined on this slide. Each of the use cases were essentially different variations of how the emergency networks are designed to handle large-scale public safety events, especially in situations where regional networks might be so degraded that the networks remain overloaded even after all non-priority calls are disconnected. I'm not going to go into full detail across these 3 scenarios because that's outlined in the document, but instead focus on a future opportunity and a risk we foresaw for enabling the use of AI. These 3 use cases are already supported by heuristics that enable monitoring of burst conditions, tracking incoming load, queue lengths, those sorts of things, with mitigations in place to reallocate resources in the event of a critical event, depending on where the bottlenecks are. The workstream did identify a possible future application of AI where cooperative AI-based agents could be applied to critical decision points in the 911 infrastructure to achieve specific goals under overloaded states. One key issue that we foresaw for enabling this scenario was the prerequisite for being able to develop and test such AI solutions. And that was the need to actually have training data and testing data that includes traffic patterns, not just related to busy days, but actual traffic patterns that mimic the actual traffic patterns that we would see in a large-scale emergency. And we don't believe that data exists. This risk became one of the key areas of focus in our recommendations section. Next slide, please. I'll hand off to Vijay for scenario 3.
Thank you, Jason. So for scenario 3, we looked at government to public service. So information going from the government and being received by the public. In this particular case, there is an excellent service called Beacon in Central Florida, which is actually put together by an organization of 5 entities, I believe, including the University of Central Florida and an industrial partner. This particular service is an excellent example of service that uses AI ML in the form of text-to-speech and optionally a large language model. So this particular service collects vital safety alerts and emergency information from trusted official government sources. On the slide, you can see information about the weather from NOAA, from IPAWS. This information comes in to the Beacon system, and the Beacon system then uses an LLM to optionally rephrase the incoming text under human supervision. So if the LLM changes anything, it does so under the human supervision, where the human can accept or reject those changes. Once either a modified stream has been produced or the original stream that came in to Beacon, that stream of text is taken and provided to a text-to-speech system, and the text-to-speech system then generates natural-sounding voice broadcasts and alerts in different languages targeted to the region's diverse communities. These broadcasts and alerts can be received by the public on a Beacon phone app, the university-operated radio channel, live stream, and TV. This service has been in operation since July 2025. So clearly, some processes need to be put in place to make sure that if the LLM is being used, it is being faithful to what came in. And if a TTS, text-to-speech system, is being used, at least there has been a panel of experts that have listened to the recordings, to the voice produced by the TTS system, to make sure that there is no disfluency in the voice, and indeed, it's understandable by the class of people that are receiving this voice. So we felt this was a very interesting application of an AI ML service in the government to public area. Next slide, please. So this brings us to our recommendations. The working group has created 3 classes of recommendations. The first class, which I'll discuss, is directed to public safety purchasers of AI and ML. The second is directed towards the FCC. And the third class of recommendations is directed to public safety industry stakeholders. The recommendations for public safety purchaser of AI cluster around two things. One, ensuring humans are in the loop, and two, ensuring transparency and privacy of these models. The human factor must underlie decisions made to choose AI ML components simply because these systems serve in an adjutant capacity that aids human in making decisions. Thus, the working group recommends foundational knowledge and workforce enablement for PSAP personnel. This will further help in human-centered design and operational fit if the workforce is aware of the advantages and disadvantages of using these technologies. Similarly, processes to foster transparency must be developed around the technology. We should make it clear where AI is being used in the system, how it is being used, and the limits of technology. So the four broad areas you see on the slide cluster around making sure humans are in the loop and making sure that there is transparency and control inherent in the system that is being used. Next slide, please, and I'll turn it over to Jason.
Thanks, Vijay. So the second set of recommendations were targeted at the FCC. There are actually 14 recommendations specified in the document, but we've sort of summarized today into 5 different buckets. The first bucket is focused on standards and interoperability, with recommendations focusing on the need for AI systems to meet consistent benchmarks in the context of emergency communications contexts. The second area was cross-agency and industry collaboration, recommending encouraging greater collaborations on the responsible use of AI, both opportunistically and for mitigating threats. The third area was focused on system visibility and reliability, which was sort of improving the understanding of 911 availability and potential issues with extreme events, perhaps potentially building on top of the existing NORS reporting data to enable the full ecosystem to start considering how AI could actually mitigate failures. The fourth area was protection against adversarial and synthetic threats. This was a scenario of concern where AI could be used to flood existing networks using synthesized calls or texts that appear to be valid. And the fifth area was focused on emerging communications infrastructure broadcast systems, ensuring that AI is applied in any part of the communications network and its implications are well understood for the rest of the network, including the public safety network. I'll now pass on to Jen for the third set of recommendations.
Thanks, Jason. The final set of recommendations are geared toward public safety industry stakeholders. The report recommends that EZNet and PSAP operators integrating AI should emphasize responsible deployment, strong governance, transparency, mitigation, data protection, and continuous evaluation. The core ideas that capture the various specific recommendations include that AI must be thoroughly tested for critical real-world conditions before operational use, that organizations should have structures that explicitly define responsibility and authority for AI systems, that the systems must be hardened against threats and designed with modern security principles in mind, that the systems must be equitable and their societal effects should be understood. Personnel should be trained to use AI effectively and to provide operational feedback. And finally, industry should remain connected to broader standards and guidance ecosystems. With that, that concludes our report on the third report of Working Group 1. So thank you very much.
Thank you very much. Fantastic. With that, I'll open the floor for comments, questions, debate. Any questions? Anybody online?
I just want to say I was recently at the NINA 911 Goes to Washington event, and a young woman from a Western state approached me. She wanted to express her concerns about the use of AI in PSAPs. She was with a state PSAP, specifically the first line where a human being typically answers a 911 call. And she thought that that was extremely important, and she gave me one specific scenario, and I encouraged her to send me an email so I could put her in touch with the working group. And I didn't hear from her again, but I did think it was interesting that she was concerned enough that she wanted to express it to someone at the FCC. So I think it's great that this was looked at. I think people are thinking about this. I think there are, there's excitement and there are also fears, and I was glad to see some of those issues addressed in the report. There's no one who drafted the report here for me to actually look at, but I just wanted to share that.
VJ, Jen, Jason, I just want to say, I think we addressed this scenario and talked about needing the human in the loop, and that AI would be used to augment human decision-making and not to supplant it. So I think the report addresses that exact concern and in the way the telecommunicator would have liked.
Agree.
Any other comments, questions before I open up for vote? Okay, so those in favor of adopting the report, say aye. Aye.
Aye.
Any opposed, please say nay. Great. With no nays, we'll call that one approved. Thank you. Smooth. Great job. Great job. All right, Brandon, pressure's on to do the same on this one. So Brandon Abley and Stephen Devine to present the report on recommendations for preventing adverse impacts on PSAPs and NG911 from 911 calls made through alternative network options.
Okay, thank you. Make the slides up, please. Okay, there's the title. Next slide, please. We have our working group members listed here, an esteemed gathering of incredible experts. It was so much fun to work with them. There was so much expertise. And my co-chair and I, while running these meetings, we're experts in some things, but not everything, right? And I don't think I speak for myself when I say that I learned so much over the course of this project. It was a challenge, but very fun. Next slide, please. We have our alternates listed here. Next slide. This is just a cover page. So I'm not going to belabor the next few slides too much because it just kind of describes the structure of the report. And certainly we've all read it, so I don't want to be redundant. But again, our first report focused on the alternative access networks that were available. And the second report focused on how those networks might affect PSAPs in 911 systems. We separated our recommendations, just like Work Group 1, into 3 categories. We have general recommendation for the commission and industry, which might seem a bit odd, but the idea there is not just the commission or not just the industry can make these things happen. And then specific recommendations for the commission, and then those for industry, and we'll get to those in a bit. Next slide. So just for posterity, these were the questions in our charge from the commission. I'm certainly not going to read all of those off to you, but we replicated those in our reports for those that might read it to not be familiar with the original notice. Next slide, please. So we identified a few themes throughout the course of the reports. One is that these alternate options improve access when the primary carrier fails or its primary means of serving the user has issues. Obvious ones are like a cell site outage where you have to roam to something else, or a satellite backup, or Wi-Fi network. But some of these newer options actually introduce some challenges to PSAPs. Of course, you won't be surprised hearing from us. We strongly advocate for NG911 to support a lot of these use cases. And we're really discouraging future action on making any changes or upgrades to the legacy E911 system. I'm not speaking strictly for myself. That is the consensus of the work group. And we'll have more info on this later, but one of the big things is that the commission asked us about new class of service values that should be made. And we actually recommend transitioning to NG911 instead, because retrofitting the networks to deliver new classes of service and upgrading the ANI-ALI data and formats for all the PSAPs and 911 systems is less productive than just moving into the next generation. So we just identified different ways of accessing the network. Again, I'm not going to read all of this slide to everybody. This just summarizes what's in the report, but it indicates the information available in E911. And once we get to deliberation, I would like to propose an amendment to one line in the report in this section. Oh, I'm sorry. Yes, I was looking at my own screen. Yes, so this is the slide that I meant to summarize. I have said all of this. Next slide, please. We talked about emergency texting. One of the key things that we want to point out, and this is coming up on other avenues, for example, those of us that are working on FIFA in various ways. So international roamers, for example, they can't really text 911 because text to 911 interim text is home routed and doesn't support local breakout. So if they're roaming on a network in the United States, they can't access their text service on their home network, so it just doesn't work. And that's also the case with some of the domestic use cases that are described in the report. I believe you went too far. Back, please. Oh, I skipped too far. I am sorry. Yes, so next slide. Caller location. I am sorry. Yeah, so with caller location information, we look at how location is conveyed in both E911 and NG911. The important thing that most of us know, but we want the commission to really be reminded of, is that in NG911, we have standardized IP-based methods to convey the caller location. Most of us have heard about Petaflow. That's an IETF standard from quite some time ago that's been adopted into NG911 standards. We also have a new report that's been published by ADIS. It's 070052, Civic and Geodetic Location Conveyance in support of emergency calling. It improves the use of what we call method tokens in the North American market. I really recommend giving that a read. There's a lot of interesting mapping between method tokens and classes of service and which method tokens should be used. If you know about the method token registry, and if you know me, you know it's my least favorite internet registry in the world for reasons I won't get into here, but it needed some additional work. The convenient thing here is that this was up for ballot right before we submitted our final report, and we were able to include it with just a day or two to spare when it was finally approved by ADIS. And we're also doing similar work under ADIS, a partnership between ADIS and NENA, but a document that will be published by ADIS for what we call the Location Conveyance Task Force. That work is wrapping up soon, but this also puts more effort into these mappings that the previous report introduced. Okay, next slide. So I had talked about emergency texting. I had skipped ahead, my apologies. But one thing that we thought to highlight in this section is that the SMS texting for someone that's on a visited network, so basically roaming, this was studied by 3GPP quite a long time ago, as was the issue for what we call temporary identifiers. So basically, if you have no callback number, you can create one in the moment and hold that for an emergency call. So there is existing work with those mechanisms at 3GPP, but they have not been broadly implemented yet. Next slide. And this is just a cover page. So we looked at various alternative networks and primary networks. Again, we know that CMRS, or for those in the general public that are following, a cellular network, is the predominant way to place an emergency call across the world. The FCC statistics place it at about 80%, as does NINA's independent research. But also, we had talked about in our first report and expanded a bit here about use of alternative CMRS networks in the case that a network is down and then backup options with your primary provider are not available. I had touched on the proposal for temporary identifiers earlier. This has actually been something that a lot of us in the industry have been trying to push for. This standard mechanism that I described was actually adopted by 3GPP in 2009. So it's not a new idea, but nobody has implemented it. But especially with these international events coming up, we sure wish that it had been. Test 1, 2, feedback. Test 1, 2. Okay, all right. We found the guilty party here in the room. So the class of service and NG911 equivalents, again, I brought this up at the beginning. Next slide, thank you, Steve. Yeah, so the class of service and NG911 equivalents, again, I touched on this in the beginning, but the focus must shift from retrofitting legacy systems and just transition to full NG911. We all know the recent rules that the Commission has implemented to advance NG911, and the country is working towards implementing them. But to solve a lot of these problems with alternate networks, we really do need to have advanced systems. Another point about class of service, or COS in the slide, of course, it's been an important data point to describe the nature of the location acquisition for the 911 call. And it does imply the type of origination service, because if you see a wireless phase 2, for example, you know it's a cell phone. If you see VoIP, you know it's a VoIP call. But it doesn't actually distinguish between the origination type and the location type. And especially with these alternate access networks, it is super important to distinguish between those two. Next slide, please. We add some additional information about PIDFlow and some recommendations that come later. And also some specific guidelines that will go into recommendations as to how to improve the way that we use service and caller and location information in NG911 to accommodate these alternate networks. But PIDFlow only provides information about the location source. We have additional data blocks that provide service info and that other information, and that's described in the report. It's kind of an obscure distinction if you aren't really deep in the standards or implementing NG911, but it's very important when we look at alternate networks again. So there's a lot of text here on the next slide. This covers some of this stuff in the first report, but goes into more detail about how this might affect the PSAP, specifically information about how fallback, for example, might be used within the same network. If you might have a 5G new radio, which is being deployed across the United States, and it's very early stages, right? But that might have to fall back to 4G. Those radio access network types have different capabilities, and it may be useful to inform the NG911 system that that fallback has been made. We also have fallback to SCS and NTN, which I'll get into in more detail in a future slide, but those are backup satellite access methods. Yeah, I'm not going to read all of this. It's in the report. But one point is that when we talk about fallback, depending, or access networks, depending on the technology used, the same PLMN, the Public Land Mobile Network ID, which is used to identify the carrier, might be used depending on the implementation, even though you aren't on the cell network anymore, you're going to space. Next slide, please. So we looked at a few cases in terms of fallback, depending on the nature of the device and its subscription capabilities. So we have a valid SIM and a roaming agreement case. This specifically comes into highlight when we look at international roaming scenarios. They do introduce additional complexity. For example, right now, most PSAPs can't receive a full E164 number, which is the international format. They're based on the 10-digit dialing plan in North America. There is some work being done in the industry that hopefully we'll get more information about publicly soon to address this in advance of these major events. Of course, in NG911, that's the default phone number format no matter what, so international numbers are not truncated. That is if it even doesn't show up as an NSI call, right, the 911 area code in IMEI. But the PSAP equipment for this kind of fallback really must support the international dialing formats and outbound calling. And everything else, the CAD system, the RMS, logging, analytics, all of that must also be able to tie back to that full phone number. And again, in this case where we have a valid SIM with a roaming agreement, interim text 911 will not work in the United States right now. So we have NSI devices in the next slide, NSI devices without a SIM. This is typical classic use case, but the interesting thing is that sometimes depending on the nature of the roaming agreement for like an international visitor, it'll often just present itself completely as an NSI call. So you don't know that the call is from an international device, it falls back to NSI, and then it just looks like an NSI call, which we have to support, but of course no telecommunicator really prefers to deal with them. They're generally limited to voice and possibly RTT. If they don't have a valid SIM present, they'll operate in what we call limited service mode, and we go into more detail in the report about what that means. I think a lot of us in 911 have a general idea of what that is, but it's a very specific thing in the specs. And it's not just if there isn't a SIM, it's more if the SIM, the credentials cannot be authenticated, as I mentioned earlier with visitor calls. So most of the additional delays in the call setup that we described in our first report, we expand upon here, is that most of the delays are related to actually scanning for someone to provide you service in the first place, especially if you aren't attached to a network already. Next slide. So we have more information about Wi-Fi calling as a backup network. Those of us that were in a previous CSRIC might remember a big report on this exact topic for 911, which was an interesting challenge in my opinion. But Wi-Fi calling requires prior feature activation and subscriber registration. We've all done this. If we set up Wi-Fi calling on our phone, they're like, you need to put in your address so that we can find you. But the voice, when a CMRS, like an LTE call, has to fall back to Wi-Fi if there's an interruption with the network. We bring this up because the voice continuity is not always seamless because the Wi-Fi calling systems are much different from the native LTE or 5G network. Okay, next slide. So we have pre-NTN SCS, as we call it, non-terrestrial networks, and supplemental coverage from space, which I should have spelled out in this slide. So one of the things that the work group had pointed out, and this is of special interest to the commission, is that the regulatory framework for SCS and the associated deployments have moved ahead of the standards-based NTN work, which is not necessarily a problem, but the industry and the commission must work together to align those two concepts. We mentioned that satellite connectivity typically provides lower available bandwidth, latency. We all know that. It'll be interesting to see in the market with the constantly improving satellite systems that we have, especially with low Earth orbit, natively supported by a cell phone. When fallback to satellite happens, exactly what the user experience is like. So another thing that we mentioned about the location with this type of fallback is that the location for the using the satellite access really depends right now primarily on device-based positioning technologies such as GNSS or in the United States GPS. And even if we were to get to the point, which we will, where we place a native voice call over a backup satellite network that's associated with a carrier, again, within the same service profile, but a different network. At this point, we're only going to see the device-based location accuracy, so it might just be GPS, or one thing we mentioned, possibly as large of the coverage area of that satellite. And that introduces interesting problems for routing, for example, especially when the individual low Earth orbit satellites are moving very fast and you switch between them frequently. Next slide. So, this slide is pretty blunt. The group's consensus is that we do not recommend new classes of service for these alternate technologies. There's a lot of argument here. I'm not going to read through all of this. The full report goes into detail. But the work group just felt that expansion of classes of service really introduces additional complexity and training and setup issues without delivering proportional benefits to PSAPs. Next slide. So towards the end of our report, we actually get to some of the specific negative impacts to PSAPs. It's good that the use of backup network options increases the likelihood that a caller can reach emergency services when their primary cell service is unavailable, impaired, or restrict. That is absolutely a good thing. But PSAPs will start to see things that they aren't used to seeing yet. And there will be changes to their equipment, especially if they upgrade to NG911. Then on top of all this additional complexity, they have to have a worthwhile understanding of some of the engineering concepts between these different networks so that they can understand what they're actually being presented about the way it was called to deliver, or the way that the call was delivered to them. I think I will go to the next slide. Again, I don't want to read all of these off to everybody. This is all in the report. So additional negative impacts that I want to highlight from this slide, some of this has already been touched on earlier. But the big thing is that a lot of backup networks right now support emergency messaging. We've seen a lot of successful deployments right now and lives saved by being able to place a text via satellite, like in remote areas. A lot of us have seen these case studies. But others may support voice but not support messaging. So really at NG911, we really need to have an end-to-end multimedia experience that supports all possible modalities for various reasons. Another point that we bring up is that alternate network options are an excellent solution when we have what we call a sunny day outage. And in cases where the geographic area is being exposed to natural or man-made disasters, the alternative networks Maybe calling it a negative impact, we could call it a challenge on PSAPs in the area, because as we have more alternative access options and the service just doesn't go down, they can still reach 911. That really complicates the information that the telecommunicator has to deal with. Next slide, please. We also touch on what we call NG emergency messaging. This is another spec that was recently produced by Addis. It's an update to the 070015 series. And that series is, to put it simply, is the NG 911 origination standard for telecommunications carriers. So the most recent revision allows what we call session mode emergency texting and over IMS. So this is much different from interim text, which might use SMS over IP, right? And then we'll establish a session from the text control center to the PSAP. But we've developed the specs where this can actually work end-to-end in a native i3 version 3 environment. And that's important when looking at messaging as an alternative access network if voice is not available. It's primarily an architectural change. There's little immediate operational change for PSAPs. And for most PSAPs, the format and protocol used for NG messaging is consistent with what was deployed under interim text and 911 rules. And we did that at Addis specifically to minimize the impacts to operations. We talk about some of the capabilities, next slide. We talk about some of the capabilities using an emerging technology called IMS data channel. This is maybe more of a 6G thing than a 5G thing, but Addis and 3GPP are already working on mechanisms for IMS data channel. It's an emerging IMS-based capability that will kind of combine the experience with messaging, video file transfer, and other application layer data in parallel with the call. Basically delivering what we've always promised with NG 911. There's always been a gap to where the 911 standards are and where the carrier standards are, and the SDOs have been working more closely together in the last 5 years or so to address that. So 3GPP has not yet standardized IDC for emergency services. Right now, Addis is working on a study, and we'll advise, our members will advise 3GPP as to what we find and what the requirements are. But IDC will require a forklift upgrade at 3GPP, Addis, NINA, and probably other SDOs too, because it's a completely separate concept. Next slide. So we talk about in both reports about SideLink as an alternate as a possible alternate network. It's a peer-to-peer mesh. You know, if your device can't reach the network, but my device can, you know, you can leapfrog. We do go into some of the issues with actually adopting this. For example, SideLink deployments and research right now focused on field responders, especially public safety broadband networks. 911 via SideLink is something that could be helpful, but it's not something that has been well researched or standardized yet. There are a lot of issues, for example, even having dedicated spectrum to do it in the first place, whether users opt in or opt out, or whether their device could be overridden to opt in if there's an emergency call that might need to hop off of your phone, and other issues. So now, next slide. Now we get to the meat of the report, which is what we actually recommend, the most important part. So again, our general recommendations are those that apply for all entities to collaborate on. It's not something that we ask the commission to do. It's not something we ask SDOs to do alone, or industry. So we do recommend that call relaying in 911 relay centers are recommended for further study, perhaps in a future CSRIC or by the industry, an entity like Addis. A big recommendation for everybody is that a strategic emphasis has to be placed on NG 911 mechanisms, and that applies to everybody. That should not surprise anyone or be or contravene any existing commission policy. Some of the things include establishing best practices for use of PIDFlow method tokens. And again, I won't go into detail about method tokens right now, but they need a lot of work. We also need to expand the use of additional data blocks. And this is important because I think in a lot of the community, there's a reasonably good understanding of PIDFlow, but not enough understanding of the additional data blocks that contain the rest of the information about the nature of the call, including service info and service type, device info, provider info, and subscriber info. These are not technical terms. The names of these data blocks should be very obvious. To develop standardized mappings and guidance for interpreting method tokens and additional data blocks related to legacy classes of service. That is ongoing work, but the work group recommends that that is encouraged by the full CSRIC. More information about method tokens. And a big item related to the first top bullet is to expand support for the ability to distinctly identify calls through relay centers using appropriate NG 911 additional data structures and enable proper handling and context-aware responses by PSAPs. Because right now in a legacy E911 environment, you don't really get to pass through a lot of the information that you would send directly to 911 if you have to use a relay center. In NG 911, there's a bridge that bridges the different media types, right? So the call taker would be able to see all parties, would be able to see the caller sign and the interpreter, and the audio would go all three ways. They'd be able to text each other. So that's the concept, but we need to study how to actually do that and consider developing rules. Next slide, additional general recommendations. So there's more information in the reports about this, but we do need to study appropriate mechanisms or configurations to limit excessive retries under different circumstances. And there are both, the common advice that we give in 911, not to hang up and call again, of course, but there are also, in the network, you can see excessive retries based on the state of the call being routed or connected to a 911 system or PSAP. It's something that needs to be investigated. Of course, we need to support full E164 callback numbers. I mentioned that earlier. That's something that's getting greater awareness, especially with the international events that the United States is hosting. Mentioned earlier, but this is in the recommendation section, that PSAPs and 911 systems need to support international dialing formats and outbound calling. One thing that we found is that in some cases, even if the PSAP is aware of the full international number, their 911 trunks aren't configured to make international calls, so they can't call back anyway. And we see some interesting alternatives like having a dedicated cell phone for calling those numbers back, or trying to call them back on WhatsApp, stuff like that. So that needs to change. The same note earlier about CAD and records management logging, all of that needs to support international numbers. And another thing, that industry stakeholders should take coordinated steps to ensure that emergency caller location capabilities for limited service calls, like international roaming, NSI calls, calls using different backup networks, that the location needs to be functionally equivalent to a regular, quote-unquote, regular 911 call in good conditions. So specific recommendations to the commission, again, I do not speak for myself or my employer. The consensus is to not develop classes of service for alternative network options. And again, to focus on NG911 migration for many of the reasons summarized here and included in the report. The second bullet is a bit redundant to that, but to ensure emergency services can adapt to a growing array of communications pathways, again, to transition to NG911, closely related to the class of service argument. And a final one for the Commission, to consider the contemporary state of standards when initiating future actions on NG emergency messaging. Again, I speak for the group, not necessarily myself, but one thing we discussed is that in a few cases, Commission action will predate the completion of a standard by like a few months. So we have to throw our work away on the standard and just follow the rules instead of being able to offer a completed consensus industry standard for advice. So for industry and SDOs, we talked about the additional data. We really do need to expand understanding and use of additional data blocks, especially to explicitly recognize satellite originated emergency calls and distinguish between terrestrial and non-terrestrial. We do have some specific things in motion at a couple of SDOs to actually implement this already, at least on the standard side, but it needs to be implemented, especially for backup networks. We talked earlier about developing standardized mappings, summarized a bit for method tokens and additional data elements, but again, that's in the final list in the report. We talked about relay centers. This is kind of redundant for general recommendations and also for industry and SDOs, because it's a bit different to work on the standards and implement them versus the stuff that the Commission itself should actually be involved with. And again, we talked about the additional data blocks. We really need to evaluate and refine how we use service type and related fields to improve access technology visibility for BSAPs. And another one, this is just for industry, not necessarily of particular interest to the Commission, I'd imagine. But some of the standards work that we're doing in North America, especially through ADIS, are getting ahead of 3GPP. And there are some examples of that in the report. And we do recommend that the industry and SDOs extend the North American standards for specifically emergency messaging globally. Because our specs and our prototype implementations are far ahead of what the rest of the world is able to adopt. And we have just 2 slides left. We want to improve CMRS as a backup network. We have that as a, thank you, next slide, yeah. We have specific recommendations on improving CMRS as a backup network. We broke this out into a separate section because, again, the mobile networks are so important because they originate the majority of calls. So we want to promote consistent delivery of key information, especially the callback number, regardless of the registration status of the calling device. Again, very important for upcoming events. We recommend studying feasible approaches for supporting emergency callback to roaming devices. We mentioned temporary identifiers, which were never implemented, but they maybe should be, but that's a recommendation to the industry. To evaluate whether devices with valid SIMs that are unregistered for normal service can perform limited emergency registration, and to encourage industry and standards bodies to study whether and how additional modalities, such as non-RTT emergency messaging, could be supported for unregistered devices. And our last slide for NSI calls, we really do need to, like a recommendation in the previous section, we really do need to find a way to call back an NSI device or one that appears to be NSI, while minimizing impacts to devices and PSAPs. They recommend that the industry should conduct a study of possible solutions for both NSI support and priority PSAP response to identify effective solutions. There is a note that ADIS might be a good place to do that research. And we do note that many alternative network options, as I mentioned a couple of times in this report, currently present as NSI calls, even if they have a valid SIM and they may be roaming. So finally, we can field any questions or deliberation.
Great. Thank you, Brandon. Any questions, comments from the floor? Anyone online?
I would just add, Steve Devine with APCO, I would just add that our work, we looked out 10 years with regard to some of the alternative network options, and SideLink as an example, that's not a mature product today, but it could be in 10 years. So we included that, and as Brandon indicated, another real challenge is the fact that alternative network access can introduce delays in the call, and then that would cause people to dial back and recall, et cetera. So we even talked about the idea of making the caller aware of the fact that their call is still in progress, and please don't redial, because that doesn't do anybody any good. So we had a lot of discussion about that, but technologies and technological adoption is something that we made some assumptions on based on our charge. So.
Great, thank you. Any other comments?
Yes, actually, in terms of
Your
deliberation.
amendment proposal too,
Pardon
right?
me?
You had a proposed amendment too. Right?
Yes, in the spirit of deliberation, I know as a co-chair, it's unusual to question our own work. But under section 3.4.1, there is a technical error on the 5th bullet, which misrepresents the insight in E911 that a telecommunicator might have about the nature of the call origination. So we do recommend striking that 5th bullet, and that is the only change.
The one that says type of communication?
Yes, sir.
Strike that one. Any other comments on that? Issues with that? Okay. Hearing no more comments, I'll ask for those in favor of the report with the agreed amendment to that 5th bullet to please say aye.
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 Aye. Any opposed, please say nay. Okay, the ayes have it and the report's adopted. Thank you very much.
Thank
Good
you
job.
very much.
Okay, on to our third report. Brian Daly and George Woodward are going to present on potential security and reliability risk in 6G and recommendations for mitigation.
Thank you for the introduction. On behalf of George and myself, this is Brian Daly. I'll go ahead and give the presentation from Working Group 3. Also, on this slide, I want to recognize Ken Kahlberg, our FCC liaison, for being with us during all our weekly calls. So thank you to Ken. Next slide, please. So just a quick review of the charter and tasks that we had. Our milestone was to produce the report, which we're presenting today. And we were directed to examine and address security and reliability risks unique to the emerging 6G network and services, and to develop a plan for the development and deployment of reliable and secure 6G networks. As you'll see as we go through this report, we did an extensive view of the emerging 6G technology and 6G standards, and we'll make appropriate recommendations when we come to the end of the report. Next slide, please. Again, want to thank all the members of the working group who put in a lot of time over the past couple of years. We virtually had weekly meetings, for the past who knows how many months, and we had good participation during each of the meetings. And again, I just want to thank each and every one of them that participated and contributed to the report. The next slide just goes through the alternates. I want to point out Martin Dolly, who stepped in from Addis after Greg Schumacher had left, and Martin took over as the editor for the document, so we appreciate his work there. Next slide, please. So as we looked at 6G, the first thing to do was to understand the timelines, use cases, architectures, and features that were coming along. And as I previously reported, one of the challenges we had is the 6G standards are still emerging. 3GPP has just begun the study phase. Well, it's actually in the middle of the study phase right now for 6G, and won't begin the normative specifications until release 21, which are targeted to complete, in the mid-2029 timeframe. So our challenge was to look forward and see where the standards are heading, but also that's an opportunity so that we can help drive the standards, especially when it comes to security and reliability. And as I previously presented as well, the capabilities for 6G, or as the ITU calls it, IMT 2030, were defined in their famous palette diagram. And what's highlighted on that palette diagram are the areas that touch security and reliability. When we look at the usage scenarios for 6G, they're really extensions of what we have for 5G. Really providing immersive communications by enhanced mobile broadband, massive communications through massive machine type communications, and ultra reliable low latency communications. But in addition, the ITU added 3 additional usage scenarios to 6G, which didn't exist in 5G. And those were ubiquitous connectivity with the ability to provide connectivity virtually anywhere on the planet. And one of the ways to get that is through non-terrestrial networks. The other is to bring AI and communications together and have AI natively within the fabric of the 6G network. And the third is integrated sensing and communication. And we'll talk a little bit more about this later because that does bring in some both security issues as well as some policy issues that we should address. Next slide, please. So again, looking at 3GPP in particular, 3GPP has completed their use cases and service requirements stage 1 study in the document that's referenced there, and it's available on the 3GPP website. These technical studies were started in June of 2025 and are just wrapping up now. Release 21, as I mentioned, will be the official start of the normative 6G work. And again, these are tied to the ITU timelines and will be complete at the end of this decade in 2029 timeframe. Release 21 timeline will be finalized in the June 2026 3GPP plenary meetings as well. Next slide. So why does 6G matter? It is the 6th generation of cellular networks when we look at it in the ITU context. It will underpin national critical infrastructure, so public safety, transportation, healthcare, energy, defense, economic competitiveness. It's going to blur the boundaries between cyber and physical systems. And it is a regulatory imperative. Security, reliability, privacy, interoperability, all of these must be addressed before deployment. The report that we're providing will provide an early forward-looking assessment of the security and reliability considerations for 6G. And we have to understand this is well ahead of commercial deployment and also well ahead of standards. We want to provide this report so that standards bodies, industry, and government stakeholders can build on security and resilience into 6G from the start rather than retrofitting it as an afterthought after deployment. And again, timelines with standards done around the 2029-2030 timeframe. commercial readiness is generally expected in the early 2030s. We'll probably see some pre-standards deployments before that, but the general commercial readiness, will occur after the standards are complete. And as I mentioned, those standards are now well underway. The key point is security decisions that we make now are going to shape the next decade and beyond as we look into deployment for 6G. Next slide, please. As we look at 6G, we have to think of the evolution of threats and what we can learn from the past. 4G, 5G, 6G, we are going to inherit risks from these earlier technologies. And these legacy vulnerabilities will persist into 6G timeframe because of interworking and fallback to previous generations. So things we have to consider are rogue base stations, insecure signaling, and API exposure that will be inherited from these previous technologies. And they will get amplified in 6G because of this disaggregation, because of network slicing, because of cloud and edge computing. We have to look at how some of those inherited risks will get amplified as we move into future generations. So we have to be able to defend against multiple generations of threats simultaneously. Next slide, please. So if we put on our security lens, we want to try to look at and see what changes with 6G. There is a general thesis that every mobile generation is more secure than the last. Well, that's true. We bring new and better algorithms and protocols in. We learn from previous technologies, but we also have to understand that as we move into the next generation, those technologies are also going to get more complex. And 6G is no different. It's just not a faster 5G. AI is going to be a control plane, not just a tool that will be used in 6G. Sensing functions are going to be added that can observe the physical world. There'll be deep resilience on cloud, software, and multi-vendor architectures, as well as support for an expanded diversity of connected devices with a wide variety of form factors and capabilities. And we're seeing the convergence of communications and computing, and as I mentioned, non-terrestrial networks for getting ubiquitous coverage. So what the result is, we're going to expand and have more consequential attack surfaces that are going to emerge as we move into 6G technology. Next slide, please. So we need to look at threat modeling. What can we as this working group do to address 6G security and privacy risks and the 6G threat landscape? Now, I know there's a lot of words on this slide, but I'll try to, summarize it very, very distinctly. The challenge is 6G standards will not be ready at this stage for several years. So the threat models that we looked at were dependent upon the system architecture or data flows which have not been developed for 6G. So what we did was we selected a set of 6G services and one or more of the threat modeling methods that aren't dependent on the strict architecture or data flows. And we used the same set of 6G services, and we developed negative use cases as an input to future 6G threat modeling. We didn't focus on a 6G architecture because that really doesn't exist yet, but we did cover emerging security directions that are expected to be reaching widespread deployment during the 6G timeframe. And some of those security directions include zero trust as well as quantum safe cryptography. The coverage can be seen on the aspects and designed to the 6G from the start. Some of these were not included in 5G, some were optional in 5G, so we had to take into account what 5G had offered as far as security and look at it as we put our lens towards 6G. And we did want to focus on the threat modeling process as recommendations for improving the overall 6G security development. Next slide, please. So the threat modeling for 6G, some of the key findings we came up with. 6G threat modeling must be use case driven. Again, with that evolving architecture and a granular system-wide threat models being premature, we had to focus on high-impact use cases like autonomous transportation, industrial automation, XR, and sensing that are going to impose unprecedented requirements for trust, resilience, and dependability. We recognize 6G is going to significantly expand the attack surface. New architectures coming about, AI native control, APIs, virtualization, sensing capabilities, all of these are going to expand the threat attack surface. And we needed to make sure that we looked at things like AI model poisoning, sensing spoofing, resource starvation, and cognitive data leakage with potential physical safety and societal impacts. The implementation correctness and product security are foundational. Many of these advanced 6G attacks ultimately are going to exploit basic flaws. Secure by design practices, zero trust principles, cryptographic integrity, robust AI input validation, all of those are essential but not sufficient on their own. And next is industry-led analysis and government support are critical. Standards bodies have to lead detailed 6G threat modeling so that we can inform normative security requirements. And the FCC and partners such as NIST should support comprehensive analysis, testing, and assurance. So recommendation is to strengthen secure product lifecycle practices and pre-deployment security, assurance, using end-to-end testing and established frameworks out of NIST or NSA, CISA, and also to ensure 6G networks are resilient, trustworthy, and fit for critical infrastructure. Next slide, please. So the threat model overview, there were really three classes of risks that we were looking at. The first, as I already mentioned, were inherited risks from 4G and 5G, including those rogue base stations, insecure signaling, and cloud API vulnerabilities. The amplified architectural risks, when we look at disaggregated Open RAN virtualization and cloud-native infrastructure, as well as network slicing. And new 6G native risks, such as AI modeling manipulation, ISAC, sensing misuse, and physical layer and radio-based attacks. Next slide, please. So the inherited vulnerabilities still matter. The security debt from previous generation do carry forward. Downgrade attacks where you move from your current generation to previous generation, those will remain possible unless we put strong protections in place. Legacy signaling weaknesses can still be exploited. 6G devices are going to coexist with 4G and 5G device potentially for decades. And backwards compatibility does equal a persistent risk, as we try to make sure that we're compatible with previous generations. So the key lesson is 6G must defend against old attacks and new ones at the same time. Next slide, please. So what 6G must defend against the past? So again, I talked a lot about the legacy risks that persist across generations. 4G LTE did introduce meaningful security improvements over 2G and 3G, but there are fundamental protocol level weaknesses, especially unprotected control plane signaling, that did remain exploitable whenever backward compatibility is required, including the 5G non-standalone and future 6G roaming scenarios. Some of the other 4G LTE inherited risks that are practical and impactful include rogue base stations. That could enable location tracking, message intercept and injection, and denial of service, as well as downgrade and signaling attacks, including paging storms that are inexpensive, persistent, and difficult for users to detect, as well as IMSI catching and SMS spoofing, which undermine privacy and enable downstream fraud. 5G did introduce new inherited risks through architectural transformation, through virtualization, cloud-native design, and software-defined networking that expanded the attack surface. And the security posture did increasingly depend on APIs, orchestration, and implementation correctness. And the key 5G risk areas likely to be amplified in 6G include the service-based architecture and insecure APIs, including network slicing and cross-slice attacks, edge computing exposure, virtualization and cloud-native vulnerabilities, as well as Open RAN disaggregation and multi-vendor trust challenges. So the takeaway, 6G security must address these legacy signaling exploits, cloud API threats, and next generation risks. Simultaneously, security cannot be designed in isolation by generation. And I know I've been making this point on several slides, but it's an extremely important one as we move into the next generation. Next slide, please. So as we move to 6G, what changes the threat model? Well, first we have integrated sensing and communication. Some of the areas that are of threat when we talk about ISAC are unauthorized sensing misuse, downstream data governance, spectrum considerations, and why the use case specificity matters. The next is AI networking. AI does improve automation and optimization, but it does add model and data attack surfaces that don't exist in non-AI native networks. This would include poisoning, evasion, and extraction of data. The importance of system-level controls and zero trust to constrain the blast radius of the attacks on that particular threat model. Ubiquitous connectivity and native NTN. This does provide additional segments and interfaces and resilience opportunities paired with security dependencies. Physical layer and radio innovations, whether it be terahertz, reconfigurable surfaces, ultra-massive MIMO, dual use and proximity attack considerations all have to be taken into account. Post-quantum cryptography, cross-generational transition planning, crypto agility, as well as dependencies on PQC in some ecosystems. And then finally, number 6 is the open forum check-in of ISAC, AI, NTN, post-quantum cryptography, and where should CSRIC focus next and why. Next slide, please. Some of the security themes that are highlighted in the report. First, security must be designed for a layered reality. 6G is not going to arrive at a clean replacement. Early deployments and long transition periods are going to mean that legacy risks, including 4G, 5G downgrade, and all the inherited threat models can remain relevant. The expanded attack surface from new 6G capabilities, 6G is expected to incorporate or rely more heavily on some of these new technologies such as AI, cloud-native software, disaggregated multi-vendor architectures, and new spectrum and radio techniques, each of which are going to introduce additional pathways for attack. AI native networks create a dual risk. They can strengthen automation, monitoring, and optimization, but can also become a target itself. ISAC introduces privacy and misuse concerns. Native non-terrestrial network introduces complexity, and post-quantum cryptography, again, it's a near-term planning issue when we need to think ahead when post-quantum compute becomes a reality. Next slide, please. So looking at the 6G native threat surface, some of the emerging technologies and novel risks. Next slide. So some of the physical layer and advanced radio threats that we've identified, certainly as we move into higher frequencies, the new terahertz band will enable extreme bandwidth, but they will create new physical layer risks. Highly directional quasi-optical propagation uh, does improve the focus, but is vulnerable to blockage, jamming, and reflective eavesdropping by adversaries with knowledge of beam paths. Uh, the imperfect channel state information is going to be a key vulnerability in dynamic terahertz environments. Channel state information errors can be exploited, leading to information leakage despite these narrow beams. Advanced radio features, including reconfigurable intelligent surfaces, as well as ultra-massive MIMO. Both of these do bring new threats into the system that need to be considered, including what's known as green jamming, which is passive jamming using reflected ambient signals and making attacks difficult to detect. There's also signal hijacking, which is the steering of legitimate transmissions toward an attacker. The environment reconfiguration attacks, which is the manipulation that destabilizes the radio environment. Ultra-massive MIMO does also enable performance gains, but introduces poorly understood hardware level risks. When you're using thousands of antennas, that can expand the attack surface beyond traditional software and protocol threats. And physical exposure of ultramassive MIMO infrastructure does create new proximity risks, including tampering, hardware manipulation, and reverse engineering. And that'll make physical security and hardware assurance critical for 6G deployments. So these attacks are harder to detect, and again, they blur the cyber and physical boundaries. Next slide, please. Non-terrestrial networks. The NTN architecture choices are going to affect the security risk. 3GPP will allow satellites to act either as a simple signal repeater with non-regenerative payload, or to host network functions, or what we call regenerative payload. Placing more functionality on the satellite does expand the space segment attack surface and threat exposure. Wide coverage also amplifies the impact. Because non-terrestrial networks cover a very large geographic area, a failure or compromise on a single satellite or ground station can cause a disproportionately large service disruption. And 6G integration remains unresolved. While 3GPP has studied 5G satellite security, non-terrestrial networks deeply integrated with 6G is still undefined and does need continued FCC and CSRIC study as architectures mature. Next slide, please. So next I'll talk a bit about integrated sensing and communication, or ISAC. Next slide. So ISAC is using the cellular networks to provide sensing of the environment around it. It gathers a mapping of the environment, determines the location, speed, and direction of passive, non-connected objects to the network. Integrated sensing is integrating the sensing function as part of the communication network, and it's a feature that's being developed as an add-on for 5G and integrated within 6G. So some of the use cases you might see with this are monitoring drone activities, for example, tracking hostile drones around restricted areas, or they can be used to enable drones to operate in all conditions by augmenting onboard sensors. The second use case is in smart factory uses, where you can sense objects on the factory floors or in a warehouse. And the third is to complement sensors on onboard vehicles that will increase the safety for transportation and automotive sectors. Next slide, please. Why ISAC is powerful and risky? Well, it's powerful because it does use the mobile networks to sense and observe the environment. It does enable transportation safety, robotics, and infrastructure monitoring, but it does introduce new risks. The new risk could be unauthorized sensing, privacy linkage from radio reflections, and manipulation of sensing data affecting physical decisions on what you're going to use that sensing data for. Next slide, please. So the sensing functions needed to realize ISAC are being built into the 3GPP architecture. The levels of integration vary from low to high. You can reuse existing cell sites for sensing equipment with the lowest integration. You can reuse spectrum and hardware. You can reuse waveform or communication signals for sensing. There are multiple sensing technologies or topologies that are possible. One is monostatic, where the same node would transmit and receive the signal that's used for sensing. There's bistatic, where separate transmitting and receiving nodes are used for sensing. And then there's multistatic, where you have multiple transmitters and receivers. ISAC does require new network functions, including authorized exposure interfaces, sensing control, radio access network, and device coordination, as well as data processing within the network itself. And spectrum availability is going to be critical because the sensing resolution is directly tied to the bandwidth of the signal that's being broadcast. And that will require access to sufficiently wide contiguous spectrum bands, so coordination among spectrum stakeholders will be needed to meet the ISAC requirements. Next slide, please. So as I mentioned, ISAC does require regulatory clarity and also FCC considerations. Since it does operate at the intersection of communications, radio location or sensing, and data collection and analytics, policy clarity is needed to distinguish communications-only operations, usually defined under Part 95, from radio location appropriate rule parts, whether it be under 90, 87, or 101. So as you bring sensing into cellular networks, does that bring into account any of the radio location rules that have to be incorporated within the cellular domain? Also, policy clarity on the use cases, the environment, on how this would work in public versus private spaces, as well as the data type that's being collected. Is it environmental data? Is it personal data? Is it biometric data? Or is it behavioral data? We want to avoid misapplication of Part 91 when evaluating ISAC use cases, and early FCC guidance can help reduce uncertainty, improve conformance consistency, as well as enable innovation while protecting the public trust. Next slide, please. So some of the non-obvious governance questions, data persistence. How long should sensing data be retained? Purpose limitation. We want to prevent repurposing or mission creep and make sure we have use case dependent risk profiles. Authority and access. Who can access the sensing data and under what conditions? And does there need to be a multi-layered regulatory oversight at the federal, state, and local levels? Transparency, the public understanding of where, why, and how sensing occurs. Increasing sensitivity as sensing intersects with people, places, and behaviors. Equality in optics, the risk of discriminatory or selective sensing in specific neighborhoods, with the key risk that absence of a clear public benefit first framework, political, social, and reputational concerns may stall adoption of ISAC. Next slide, please. So again, some of the key unresolved policy issues, how to establish baseline transparency and notification expectations. Do there need to be public disclosures of sensing presence, purpose, and governance? How to operationalize pre-deployment risk assessments, especially for sensitive environments or populations, how to ensure accountability and auditability, access across operators, vendors, and third-party applications, how to align ISAC governance with existing legal frameworks, the FTC Act, for example, for consumer protection, Fourth Amendment ECPA, and the state privacy and biometric laws, as well as emerging AI governance requirements and how to remain adaptable to evolving federal initiatives such as the Safer Skies initiative under the FAA. Next slide, please. So now switching to AI native networks, looking at intelligence as an attack surface. Next slide. So AI is both a shield and a target. It can be used for resource allocation, security monitoring, and automation and self-healing within the network, which are all very positives. But it does introduce new attack vectors, as mentioned previously, including data poisoning, model inversion, as well as evasion and manipulation. So the risk is going to shift from protecting networks to protecting decision making. And a compromised AI can make confidently wrong decisions at machine speed. Next slide. So AI native is going to be a fundamental shift in 6G. 5G and 5G Advanced do use AI, but it's an enhancement primarily to optimize existing air interface network functions. 6G is going to represent a structural shift in being really AI native by design. And AI is going to be embedded virtually in every network element from the onset, in the network architecture, in devices and applications, in deployment, management, and operations. AI native 6G systems will leverage machine language, deep learning, and neural networks as core enablers. It will improve robustness, performance, and efficiency across diverse traffic types, ultra-dense deployments, as well as challenging spectrum environments. The ATA 6G Alliance did identify AI native wireless as a core 6G goal and did underscore its importance to future network capability. So policy and security implications are focus areas. CSRIC 9 did examine AI/ML impacts on security and reliability. NISC is developing AI-focused cybersecurity profiles and controls, and continued industry engagement with NIST is critical to managing the 6G AI risk. So the key takeaway is AI is in 6G is foundational, not optional, and it's going to require early attention by governance, security, and reliability. Next slide, please. Persuasive intelligence as a target and as a weapon. Again, we looked at the various attacks against AI/ML models, and the security of the network becomes synonymous with security of its AI models. We look across the various types of attacks that can include data poisoning. This is where a distributed or federated learning environment, a malicious actor, can inject crafted malicious data into the training set, and that could corrupt the resulting model, causing it to make incorrect decisions or exhibit biases or contain hidden backdoors that the attacker can exploit later. Model inversion and execution is where an attacker can repeatedly query a deployed AI model and analyze its outputs to reverse engineer the model itself, and then from that they can exploit that model. Evasion attacks, where an adversary can create malicious inputs that are intentionally designed to be misclassified by an AI model, and that could be used to bypass an AI-powered intrusion detection system or to trick the network into making a disastrous resource allocation decision. And attacks on explainable AI. This is where, as trust in AI decisions become paramount, XAI techniques are used to explain why a model made a certain choice. However, those mechanisms themselves can be attacked, and an adversary can manipulate the explanation output to make a biased or malicious model appear fair and trustworthy, thus undermining the entire system of governance. AI as a weapon is the other potential threat. The same powerful AI capabilities that are going to optimize 6G networks can be leveraged as a weapon against that network. They can leverage AI to analyze network defenses, find vulnerabilities, and launch highly sophisticated, adaptable, and large-scale attacks on the network. Next slide, please. Some of the architecture and infrastructure considerations as we look at disaggregating the 6G network, making it cloud native and virtualized. Next slide. So Open RAN, or ORAN, does disaggregate the RAN to enable a multi-vendor ecosystem. It does introduce new network functions and interfaces that increase interoperability opportunities, but that does also expand the security and integration challenge. Some of the key ORAN architecture elements include the lower layer split, an open radio unit, open distributed unit with an open front haul architecture, the service management and orchestration framework using service-based architecture, third-party XApps and RApps via the RAN intelligent controller, as well as cloud infrastructure supporting cloud-native network functions. Security has improved. The ORAN Alliance has strengthened security specifications since CSRIC 7. And ADIS has defined the Open RAN minimum viable profile that has established baseline security and interoperability requirements for North American deployments. And this is of strategic importance for 6G. Open RAN is considered deployment ready and expected to be reusable in 6G. Long-term benefits depend upon 6G compatibility with the lower layer split, the service management and orchestration, the RAN intelligent controller, as well as the OCloud. And we want to avoid fragmentation that requires continued coordination between 3GPP and the ORAN Alliance. The takeaway: sustained industry engagement on security, orchestration, and multi-vendor integration is going to be essential to prevent bifurcation of 6G standards and to protect critical infrastructure. Next slide, please. So CSRIC 8, they did have findings on virtualization that do remain highly relevant to 6G. But as we move to 6G, the scale and criticality do increase as cloud native functions and virtualized infrastructure are expected to be far more prevalent in 6G than we had in 4G and 5G. Some of the key drivers for virtualization in 6G include migration from dedicated hardware to commercial off-the-shelf servers, to reduce cost as well as simplify operations, as well as cloud-native containerized software to enable elastic scaling to support massive device density, as well as more efficient use of compute resource as traffic patterns are dynamically changing. We are going to see hybrid infrastructure that are going to persist. Specialized hardware remains necessary for performance-critical functions and radio. However, virtualized and cloud-native core access RAN and edge deployments will continue to dominate 6G architectures. So what are the security implications? Again, it goes to expanded attack surfaces because of the virtualization, containers, orchestration, and edge deployment. The CSRIC 8 cloud security recommendations for 5G should be applied to 6G, with emphasis on secure lifecycle management, isolation, and monitoring. So again, the takeaway: 6G security and reliability do depend on treating cloud-native infrastructure as critical communications infrastructure, not traditional IT. Next slide, please. Post-quantum cryptography. Next slide. So as we move into the 2030s, the time frame when we'll see 6G, we see the threat emerging for cryptographic relevant computers that will be available to break widely used asymmetric cryptography or public key cryptography that's used in the cellular networks. Symmetric crypto or secret key cryptography solutions are still considered safe, however. Asymmetric cryptography, again, is used extensively in mobile network infrastructure and devices today. They're currently used in 5G and also expected to be leveraged as we move towards 6G. The goal is to secure against both quantum as well as classic computers with deployable without drastic changes to the existing communication protocols and networks. Next slide, please. So there are a number of different threats as we look in the quantum era. The first is harvest now, decrypt later. This is where attackers capture the data, encrypted data today, knowing that they can't decrypt it using current technology. But when cryptographically relevant quantum computers become available, they would be able to decrypt that stored data. So the significant threat is long-term confidential data. Quantum decryption by a cryptographically relevant quantum computer may take time, but can eventually intercept and decrypt communications. This would allow attackers to gain access to sensitive information without detection. There are also quantum impersonation attacks where adversaries can use quantum capabilities to exploit public key cryptographic systems and impersonate legitimate users. Quantum man-in-the-middle attacks, which are similar to the classic man-in-the-middle, but with quantum relevant computers, they can tamper with or alter messages between the two parties. And finally, side channel attacks, where you can exploit indirect information, such as timing, power consumption, electromagnetic emissions, which are both a threat to both classical as well as post-quantum cryptography algorithms. Next slide, please. So quantum computing does threaten existing cryptography. PQC must be adopted in 5G advanced and 6G, be crypto agile, as well as interoperable across vendors. There are standards alignments underway. NIST has standardized algorithms and made them publicly available. The IETF has integrated PQC into core security protocols, and 3GPP and the ORAN Alliance are mandating specific algorithms consistent with the SISTA guidance. The key takeaway for policymakers, PQC must be treated as a generation-independent infrastructure transition, requiring early deployment, standards coordination, and operational readiness, not deferred until 6G. Next slide. This is more background on post-quantum cryptography in mobile systems. The diagram on the top right shows where these asymmetric crypto algorithms are used in 5G systems, and those are the ones that have to be considered as we move forward into 6G. Because as you recall, it's those algorithms that are susceptible to post-quantum crypto techniques. Again, there's many different standards that are underway and are addressing that. And as we move into the 6G era, we should all be cognizant and aware that post-quantum cryptography is of consideration in the 6G timeframe. Next slide, please. So shifting gears a bit to the reliability. Reliability is a core security requirement. Society is dependent on wireless networks, and that dependence will continue to increase. As we look to 6G, we are looking for zero outage characteristics, self-healing networks, and seamless terrestrial and satellite coverage. AI will improve reliability, but again, it also introduces new failure modes. Next slide, please. Some of the key themes on reliability and resilience. Higher dependence drives higher expectations. Again, it's the society is going to rely more on mobile networks for commerce, public safety, and daily life. So the expectations for resilience will continue to rise. AI, as we already talked about, can improve reliability, and AI-assisted network optimization is expected to improve robustness and reduce overhead. Self-healing and zero outage aspirations should be in the early 6G requirements as we anticipate stronger automation for fault detection, isolation, and recovery. Ubiquitous connectivity does support resilience because we'll have a tighter integration with non-terrestrial and other networks that can provide backup paths and wider coverage. And finally, the reliability caveat. The AI ML black box behavior can be difficult to validate, and the reliability gains will require robust validation, monitoring, as well as governance. Next slide, please. So what must be built from day one? A zero trust architecture. That is, there's no implicit trust in the network and need continuous authentication, authorization, and monitoring. Secure cloud native design with hardened APIs, secure orchestration and lifecycle management, and open RAN security alignment to avoid fragmented or incompatible standards and secure multi-vendor ecosystems. Next slide. So on to the recommendations. So the recommendations for industry. Continue to influence 6G standards work, whether it be in 3GPP or other relevant standards bodies, so that we maintain alignment with ORAN specifications and avoid conflicting and disaggregated RAN standards. Build in zero trust architecture, enabling features end-to-end between the air interface, the radio access network, the core, and the management and orchestration layer, so that we have strong session-based authentication and authorization, protection for data in transit, at rest, and in use, as well as continuous monitoring. We want to formalize security standards and best practices for secure use of AI in communications and critical infrastructure. We want to accelerate and implement PQC, post-quantum compute readiness, across 5G, 5G Advanced, as well as 6G. We need to treat PQC as a cross-generational issue, as well as support crypto agility and interoperability testing. We want to support and deploy TLS and MTLS 1.3 for relevant 6G interfaces and systems, as well as perform and maintain a detailed evolving 6G threat analysis to inform normative security requirements as architectures and use cases mature. Next slide. The recommendations to the Commission. Continue a focused study via future CSRIC work, perhaps, on security implications of ISAC, including spectrum needs and governance safeguards appropriate to communications versus sensing and radio location functions. Continue a focused study, again, potentially via future CSRIC work, on the security implications of NTN integration in 6G. Continue a focused study via future CSRIC work on security of AI used for communications critical infrastructure. And revisit 6G security as standardization and use cases evolve, and recognizing that this report is an early assessment in a multi-year cycle. Again, those standards are going to be complete in 2029. Consider convening a future CSRIC effort to develop a 6G-focused cybersecurity framework profile and best practices similar to what prior CSRIC work did for earlier generations. And collaborate with NIST to support a post-quantum compute interoperability testbed to help vendors and operators meet expected timelines. So with that, I think the next slide is the end of today's report. Yeah, the final message, just what the CSRIC should remember. 6G security is not incremental, it's foundational. The attack surface is going to expand into AI, sensing, and physical systems, and early action can reduce long-term risk, avoid costly retrofits, and strengthen U.S. leadership in secure wireless. Security, reliability, and innovation must advance together. 6G can unlock transformational benefits. Those benefits must depend on trust. And CSRIC 9 does provide early guidance to ensure 6G is secure by design, reliable by architecture, and governable at scale. And that concludes the presentation from the working group.
Thank you, Brian. Very comprehensive. Any comments or questions from the floor?
I have a few. Brian went over his 5-minute allotment.
Yes, I did, George. Thank you.
But adding to that, and I have some, I want to introduce some edits and additions before we go to approve the report. But prior to that, Brian acknowledged the exceptional team that we had in Working Group 3. I want to obviously call out Brian. Working with Brian, co-chairing is like having a brother that's a Heisman Trophy winner. I mean, it's absolutely incredible. And so a huge thank you, Brian, to you from me and our entire group. So thank you very much. The edits, Suzanne, can I go through them kind of quickly by page, not the edits themselves,
Absolutely.
but the content?
Can you kind of characterize them and explain where they came from and
Yeah.
why they're being accepted and that they'll be part of the vote?
That'd be perfect. Yeah, and that's what I'm prepared to do. So we had just a couple of redundant words, a few just minor cleanup edits, and a couple of confusing pieces around referencing sources that are very easy cleanups on page 7 and 8 to the figures there for citing the sources. The sources are actually in there. The error is in not seeing that they're in there. So it's pretty quick cleanup there. There's some redundant words on page 12 that I highlighted in your copy of your report. And then a tiny bit more substantively on pages 18, 19, 27, and 32, we have some last-minute comments that were added by ADIS. They're good comments. They're straightforward. They add to the quality of the report, and we would move to accept them as is and incorporate them in. Lastly, we've got.
I'm sorry, George, can you just explain a little bit that they're giving additional references and they're.
Yes, it's references is probably reasonable. I'll go with that. Additional references, just adding additional information to the content that was in the paragraphs that they added to, that enhance the paragraphs themselves, the information in the paragraphs themselves.
Right, like the fact that there's some added studies out there that bolster what's written.
Yeah, correct. Yeah.
Yes. Yeah.
Yeah, I think the key point is it doesn't change the meaning of the report. It just goes and enhances it with some further referencing material.
Yeah, and that's definitely applies to those pages 18, 19, 27, and 32. The last is on pages 37, and there's a couple of words that spilled over into 38, but largely additional information offered by ADIS regarding inherent threats in our table. They specifically added in one additional threat that's called out elsewhere in the report, and Brian brought up in his presentation, and that was around harvesting now and decrypting later. It is referenced multiple times in the report. It was not in our table for inherent threats, and fits in there very well, and we would move to accept that as is as well. Brian, did you? No, Brian, you're not allowed to comment. You went over your 5 minutes. So. No, do you have
I think
anything else
you've covered it all, George. Thank you.
All right. Any questions or comments on what we just sort of introduced as edits, and then, of course, any questions to Brian specifically on our report? And then I'll turn it back over. Thank you.
Great. If there are no more comments from online or the field, we're ready to take a vote. So with those in favor of adopting the reports with the agreed upon amendments, which included some grammatic changes, cleanup edits, and a few additional cited sources, and a threat mentioned. Okay. If all those for, please say aye.
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 Aye. Aye.
Aye.
Those opposed, please say nay. The ayes have it, and with that, the final report is adopted. Congratulations, everybody.
Thank you very much.
All right, if I could just second Todd's thanks to everyone on the CSRIC and to all the working group members. This has been a tremendous effort over the last couple of years. I would like to thank the commission for, I think I did that the last time, for leadership in actually assembling this group. This is a tremendous display of exactly how, at this moment in history where we do face significant challenges, and we all see in the news some of the geopolitical tensions around the world and the challenges that we face in this generation. This is a demonstration of exactly how we're going to be able to provide for the safety of our nation, to ensure that our national security interest is provided for and attended to ensure that each and every one of us can make it through this together. We can make it through this safely, and we can emerge on the other side regardless of the challenge that we face. I do also want to thank the Commission for your forward thinking and how you're looking at the emerging threat landscape and how you're looking at the impact that the Commission can have. And the work that's done here by CSRIC is not just a tool that's used by the Commission, is a tool that's used by several of us across the interagency. The work that you all did here lays a tremendous foundation that we use in our various authorities to try and achieve synergy along with the Commission to improve the national security landscape. So thank you very much for the work that's been done here, and thank you to the team that helped bring this group together.
And now we'd like some final remarks from Zenji Nakazawa.
Oliver Wendell Holmes once wrote, I think the greatest thing in this world is not so much where we stand as in what direction we are moving. You know, when I look around the room and think that over the past 2 years, this committee has helped define that direction through careful analysis, candid discussion, and sound judgment. You took on complex challenges and made the path forward clearer for policymakers, innovators, and the public. You advanced a roadmap for rigorous industry standards and a more risk-averse approach to artificial intelligence and machine learning. You elevated critical priorities for 911 and next generation 911, helping position us at the Commission for continued modernization. And you strengthened our understanding of network resilience, identifying vulnerabilities, evaluating alternatives, and recommending practical improvements to ensure the public can rely on 911, especially in moments of crises. You also helped shape the future of wireless, advancing the security and privacy foundations of 6G and reinforcing U.S. leadership in this space. Now, this is consequential work. It strengthens our nation's competitiveness, our security, and our capacity to innovate. Just as important as what you produced is how you did it, with rigor, with candor, and with a clear sense of responsibility for the public interest. On behalf of the Commission, thank you for your service and for the technical expertise you brought to bear on this effort. I also want to thank our co-chairs, Billy Bob Brown, Todd Pyatt, and our FCC liaisons, Logan Bennett and Kurian Jacob, and especially Suzanne Cameron for your stalwart leadership throughout this whole process. Really fantastic work. At the end of the day, our mission is simple: to ensure that the communication systems people depend on, especially in their most critical moments, are secure, reliable, and there when they are needed most. Because of your work, we are better positioned to meet that mission today and better prepared for what comes next. Thank you so much. Fantastic work. That's up to you. You all are Heisman Trophy winners.
Thank you, Zenji. I can't say much to top that, to thank all of you, but I hope you know that you all have my deep appreciation. All the work that's been put in as members of CSRIC 9, as experts on the working groups, as for the co-chairs, liaisons, for Kurian and Logan, who have acted as my deputies, and their hard work. It's been a pleasure working with all of you on CSRIC 9. Thank you. And with that, I announce the 7th and final meeting of CSRIC 9 is officially closed. See you next time.